If you've watched any of my presence center reviews on the channel, whether that's the Shelly Presence Gen 4, the MEROSS MS605 or any of the others that I've tested, you'll have heard me use the word mmWave a lot. It gets printed on pretty much every box now, but it turns out that mmWave isn't quite as simple a term as it looks, and what's actually going on inside these sensors can vary a lot more than the label on the box suggests. So in this video, I want to break down what mmWave actually means, why some sensors are so much better than others at spotting you when you're sat still, and what you should actually be looking for the next time you're buying a presence sensor for your smart home. Hey everyone, my name's Simon and welcome to Byte of Geek, a channel that's all about home assistant and smart home technology. So let's start with the term itself then, mmWave or mmWave as it's generally labelled. That refers to radar that technically operates at frequencies between 30 and 300 gigahertz, which is quite a wide range. If you look at a lot of the present sensors on the market, plenty of them are actually running at 24 gigahertz, which is close to that boundary, but technically still just outside of it. And some of the cheaper ones are down around 10 gigahertz, which is a long way outside the mmWave range altogether. What's happened is that mmWave has basically become a marketing term for advanced radar-based presence detection rather than an actual frequency claim. So when you see it on a box, take it as a rough indicator rather than a guarantee of anything. But here's the thing though, the frequency printed on the box isn't actually what determines how good a sensor is. What matters far more is the radar architecture underneath it, and there's two main types that you'll come across. The first is CW Doppler radar, CW standing for continuous wave. This transmits a constant signal and picks up movement by detecting the Doppler shift in whatever bounces back. It's cheap, it's simple, and it's low power, which is why you'll find it in a lot of the more affordable sensors. The problem is, because it has no distance information at all, it can't tell the difference between you sitting in a chair and a fan spinning across the room or a curtain moving in the breeze. That's also why these sensors can be so hit and miss at detecting someone who sat almost completely still, because they're relying purely on picking up tiny bits of movement with no way to isolate you specifically from whatever else might be going on in the room. The other type is FMCW radar, which stands for Frequency Modulated Continuous Wave, and this is the one that actually solves that problem. Instead of a constant signal, it sweeps its transmit frequency over time, and that lets it measure distance as well as movement. That distance measurement is what gives it something called range gating, which basically means it can focus in on a specific distance. For example, your desk chair a meter away and ignore everything else that's further out. That's the real reason FMCW sensors are so much more reliable at holding presence on someone who's sitting still. So now we understand architecture matters more than the frequency, let's quickly run through what you'll actually find at each frequency band, because there's still some relevance to it. At around 10 gigahertz, you're typically looking at a CW Doppler sensor, and these are your budget options. They're fine for basic motion triggers, but I wouldn't rely on them for anything that needs proper spatial detail. And detecting someone sat perfectly still is going to be a bit hit or miss depending on the implementation. 24 gigahertz has historically been the most common frequency in consumer smart home sensors, and it's still incredibly widely used today. You'll find both CW and FMCW versions at this frequency, so it really does depend on the specific product. A well-made 24 GHz FMCW sensor can genuinely outperform a poorly implemented 60 GHz one, so don't assume higher frequency automatically means better. Then you've got 60 GHz, which is where the Shelly Presence Gen 4 that I reviewed sits. This frequency range gives access to much wider bandwidth, and when that's combined with FMCW and decent antenna design, it means the sensor can pick out much finer detail than you'd typically get further down the spectrum. This is where you start seeing things like zone detection, multiple person tracking, and even the ability to build up basically a 3D map of everything that the sensor's picking up. And then right at the top, you've got 77 to 81 gigahertz, which is what you'll find in automotive radar, adaptive cruise control, that sort of thing. It's genuinely overkill for a smart home sensor. The range and precision you get is designed for tracking vehicles at speed, not knowing if someone is sat at their desk. Now, there's a common misconception that a higher frequency automatically means a better sensor, and that's not quite right. What actually determines how well a radar can tell two objects apart is something called bandwidth, and the easiest way to think about that is a bit like a camera resolution. A sensor with more bandwidth to work with can pick out much finer detail, a bit like the difference between a sharp high-resolution photo and a blurry low-resolution one. Higher frequency bands like 60 gigahertz tend to have more of that bandwidth available to them, simply because there's more room up there in the radio spectrum for them to be able to use. But it's really that extra bandwidth doing the work, not the frequency itself. So a well-built sensor running at a lower frequency, as long as it's making good use of the bandwidth that it's got, can still outperform a more limited, lower resolution sensor running at a higher one. So how does all this compare to a standard PIR sensor, the kind most of us have been using for years? Well, PIR sensors detect changes in infrared heat, and they're great at spotting someone walking into a room. The problem, and I'm sure a lot of you have hit this in Home Assistant, is that as soon as you sit still, the PIR loses you, and your lights or heating will switch off even though you're still sat right there. I ran into exactly this in my kitchen diner before I swapped over to the Shelly Presence Gen 4. The PIR I had installed was great at catching me walking in, but the moment I sat down at the table, it had no idea I was still there. That's really the whole reason radar presence sensors exist. A capable radar sensor, one built on FMCW with decent implementation, can hold that occupied state through stillness, so your lighting and heating automations behave the way you'd actually expect them to. So pulling all this together then, what should you actually be looking for the next time you're buying a presence sensor for Home Assistant? Well, first, don't assume a 60 gigahertz or mmWave label on the box guarantees better performance on its own, because as we've covered, it really doesn't. Where you can find it, check whether the sensor's using FMCW radar rather than basic CW Doppler, and look at whether it supports zones or distance measurement, because that's usually a good sign you're dealing with a more capable implementation. I'd also always look for real-world reviews, ones that test someone sitting still for an extended period, because that's exactly where the cheaper implementations tend to fall apart. And don't overlook the firmware. The same radar chip can behave completely differently between two products, because a lot of what makes these sensors good or bad comes down to how well the firmware's been tuned. However, that's only part of your decision making. You also need to understand how you'll be using the sensor in your smart home. If you want something that's a simple step up from a PIR, something that detects you when you're in the hallway or in the bathroom, or somewhere where you just need the lights to turn on when someone enters the room, then consider a sensor in the Tier 1 category. These are low budget devices that come without the complexity, and whilst they might stop detecting you when you stand still, it won't be the end of the world. If you're after something that can detect you sat at a desk or on your sofa so that you can turn devices on and keep them on, then consider buying sensors in the Tier 2 category. These are perfect for when you'll be spending long periods of time sat still. They'll allow you to focus on the area of detection without interference in the background. And finally, choose Tier 3 devices if you need multi-person tracking and high sensitivity detection for situations like fall detection or sleep monitoring. These devices will generally be the most expensive and likely have more complex firmware and configuration, but the trade-off should be worth it in the end. However, absolutely don't go wasting your money on these types of sensors when you just want a light to turn on in something like a closet. It's worth noting as well that both Tier 2 and Tier 3 devices will almost always have more setup involved to get them working just right. Out of the box, the sensor will work, but you'll need to tune these devices according to the location and the environment you're placing them to really get the best out of them. So there you go. Hopefully that clears up what mmWave actually means, and more importantly, why it's not necessarily the number you should be paying attention to when you're choosing a presence sensor. The architecture underneath, whether that's CW Doppler or FMCW, and how well it's been implemented matters a lot more than whatever frequency happens to be printed on the box. If you found this video helpful, then I'd appreciate a thumbs up, and why not subscribe to the channel for more smart home content like this. But as always, thanks for watching, and I'll see you in the next video. Bye for now.